Hello and welcome to another episode of Maths with Mrs. Banks, where we make maths fun and easy to learn. And in this video, we're going to look at how to solve simultaneous equations for mathematics grade 10. On that note, please don't forget to subscribe, click like, hit the notification bell so you don't miss out on any new videos we upload in the future. Share this with your friends on all social media platforms, and if you have any questions or video suggestions you'd like me to make, please comment down below with the topic you'd like me to cover and the grade you'd like me to cover, or simply send all that to the contact details provided in the description box. Now back to the video. Simultaneous equations are equations that require you to solve for more than one variable at the same time. In other words, instead of just solving for x or solving for y on its own, you solve for x and y or z and w and all that. Now, there are three methods of solving those simultaneous equations. The first method is through substitution, and the second one is by elimination, and the third one is solving graphically. We're going to look at all these methods in detail in this video, so let's start. Method 1 deals with substitution. Now you will be given a system of equations. In this case, you're given two equations because there are two variables that you're supposed to solve for, and that is x and y. Notice that if they want you to solve for three variables, x, y, and z, for example, they will give you three equations. If they want you to solve for four variables, they will give you four equations, and so on and so forth. So the number of equations must match the number of variables that you're supposed to solve for. Now, in the method of substitution, what you do is you choose the easiest equation on that system of equations, and you express one variable as the function of the other. Instead, for example, in this case, express x as the function of y. In other words, make x the subject of the formula. So how do you do that? You go from equation 1, right? We're going to express x as a function of y, so that becomes x equals to y plus 1. You simply take y to the right hand side. Now what you do is you substitute all this back into equation 2. You therefore get 3 equals to y minus, where there is x, you substitute y plus 1. And you proceed to solve like you would any normal equation. So expand, that is minus 2y minus 2. Take all the numbers to the left hand side. Add like times. 3 plus 2 is equals to 5. Let's fix that. 3 plus 2 equals to 5. Y minus 2y equals to negative y. Therefore, multiply both sides by negative. So you're left with negative y equals to, negative 5 equals to y, or y equals to negative 5. You found your y. Now what you do to find your x is to substitute this y into the x. Which x? The x that you expressed is a function of y. Now all you do is substitute for the value of y. Therefore, x equals to, for y you put negative 5 plus 1. Therefore, x equals to minus 5 plus 1, that is equals to negative 4. And that is your solution. X equals to negative 4 and y equals to negative 5. So what you do next is you check, because you're not done. You check. How do we check? You check for each equation by equation, to see if what you got matches with what the equation says. Now, let's bring those equations back. The first one is, here is x minus y equals to 1. That's equation 1. And the second one is 3 equals to y minus 2x. X minus y equals to 1. Okay, that's that equation. X minus y equals to 1. That's equation 1. X minus y. Let's fix that. X minus y equals to 1. That's equation 1. And equation 2 is 3 equals to y minus 2x. Let's just put that out there. Now what you do is now you check, you go left hand side, you substitute. Remember, our x equals to 4 and our y equals to negative 5. So you substitute. For x you put negative 4, then for y you put negative 5. That's the left hand side, just the left hand side only. That is equals to minus 4. Negative 5 minus negative 5, that is equals to plus 5, which gives us therefore that is equals to 5 minus 4, or minus 4 plus 5, that is equals to 1. And that is equals to the right hand side. Which right hand side am I talking about? This right hand side. This is the left hand side that we were checking by substituting back, and then it is equals to the right hand side. Yes, so this solution checks out for equation 1. Let's see if it checks out for equation 2. Because the left hand side will already have that sorted out. There it is equals to 3. So we don't have to waste time with that, but let's figure out what the right hand side substitutes into. So we go right hand side equals to, for y that is negative 5, where there's y we'll put negative 5, where there is x we'll put negative 4. That is equals to negative 5. Negative 2 times negative 4, that is plus 8. That is equals to 8 minus 5, or negative 5 plus 8, that is equals to 3. Meaning that which is equals to the right hand side, left hand side. So yes, it checks out. Now the answer, therefore, x equals to negative 4 and y equals to negative 5 is the solution. That is the solution. And that is how you solve by substitution. We're going to look at another example on how to solve using the method of substitution. We're also given two equations in a system with 2 variables that we need to solve for. First, choose one equation. We'll choose the first one and choose a variable you would like to make the subject of the formula. I choose y. So we go from 1. All right. For y equals to, take everything to the right hand side, that becomes 100 minus 3x. Therefore, divide both sides by 4. Okay. Divide both sides by 4. Let's fix that. Divide both sides by 4. Okay, the 4's here cancel out. And you're left with y on the left hand side. Therefore, y equals to let's fix that. Therefore, y equals to 100 minus 3x. Okay. 100 minus 3x over 4. And now you substitute. Substitute into equation 2. Substitute into 2. Therefore, notice that you didn't have to start with equation 1. You could start with equation 2 if you wanted to. That's still okay. Substitute into 2, therefore. All right, where there is y, we put 100 minus 3x over 4. So that is 4 in bracket 100 minus 3x over 4 minus 19x equals to 12. Okay. Let's fix that. We don't have All right, space, so we go 4 in bracket 100 minus 3x all over 4 minus 19x equals to 12. Right, the 4's cancel out, as you can see. The 4's cancel out, and you're left with, on the left hand side, 100 minus 3x minus 19x equals to 12. Therefore, add like terms. Minus 3x minus 19x, that's negative 22. X plus 100 equals to 12. Take the 100 to the left hand side, and you're left with negative 22. X equals to 12 minus 100. 12 minus 100, that is equals to negative 88. Now, therefore, divide both sides by negative 22. So that is negative 22. X equals to negative 88. Divide both sides by negative 22 to get rid of the negative 22 on the left hand side. If you need any help with solving basic equations, I've done a video. Please go check it out. The 22's cancel out and the negatives make a positive. Negatives make a positive. 22 goes into itself once and into 88 4 times. Therefore, x equals to 4. Now, you've got your x equals to 4. So you substitute that x back into the y. Which y? This y. All right, now substitute into y. Okay, remember your y equals to 100 minus 3. Instead of x, you put 4, because that's what x is, all over 4. And that is equals to, therefore y equals to 100 minus 3 times 4, that is 12, all over 400 minus 12, that is equals to 88. So 88 over 4, that is equals to 22. And that is your answer there. Of course, you check, and then after checking, you go, therefore, x equals to 4 and y equals to 22 is the solution. Remember, when you check, you must check that both x and y hold for equation 1, and they also hold for equation 2. That's how you check. And for them to hold, and that's how the answer is. Now, for them to hold, obviously, your left-hand side must be equal to the right-hand side on both occasions. Now, the next method is the method of elimination. And this method, basically, you'll be given a set of equations. 2 variables that need to be solved will come with 2 equations. Now, in this case, look out for a variable, right? In this case, you've got y. That has, in each of the equations that you give it, that has the same or similar constant that you can either add together or subtract together to eliminate. In other words, get rid. In other words, they must add to 0. For example, y plus negative y will give us 0. So what you do is you take these equations and you simply add them. So you go 3x plus y equals to 2, and then you add that to 6x minus y equals to 25. All right, you add how? Let me show you. plus. All right, so you go 2 plus 25 from the right hand side, obviously. 2 plus 25, that gives you 27. Gives you 27, and then you go equals to y minus y, y plus negative y, that's the same as y minus y, which is 0. So that gives you 0 here, right? And then 3x plus 6x, that is 9x. 3 goats plus 6 goats, that is 9 goats, that is 9x. Let me fix that. 9x plus 0 equals to, meaning that therefore 9x equals to 27. Now you divide both sides by 9 and you end up with, the 9's cancel out on the left hand side. That leaves you with x. Now 9 goes into 9 once and into 27 3 times. So therefore you end up with, therefore x equals to 3. Let me fix that. Therefore x equals to 3. Now what you do is you substitute this back into any of the equations. In the case of elimination, when it comes time to substitution, you substitute, choose whichever equation. Choose the simplest. I choose number 1 because that is the easiest. Always work with the easiest. Always work with the easiest, because that way you minimize the number of mistakes you make. Substitute into 1. Okay. Now therefore 3, where there is x, you put 3 plus y equals to 2, meaning that 9 plus y equals to 2. Okay, take the numbers to the right hand side. Okay, y equals to 2 minus 9, which is equals to negative 7. So your y equals to negative 7 and your x equals to 3. You check, obviously. Next step is you check. Remember, when you check, you must check equation 1 and check equation 2. So let's see what the equations look like so that we can recreate them. So the first one is 3x plus y equals to 2. 3x plus y. 3x plus y equals to 2. And the second one is 6x minus y equals to 25. 6x minus y equals to 25. Now we check the left hand side. Remember? Okay, let's see. Our x is equals to 3 and our y equals to negative 7. Okay. X equals to 3 and y equals to negative 7. So you substitute them like that. 3 times 3, that is 9. Minus 7. 9 minus 7 equals to 2. Is it equals to the right hand side? Yes, definitely. It is equals to the right hand side. So this one checks out. And the next one, left hand side, equals to, remember, x equals to 3, y equals to negative 7. So you put 3 where there is x minus negative 7, which is equals to 6 times 3, that's 18, minus negative, that is plus. 18 plus 7, take out a calculator if you need to. 18 plus 7 will give you 25. Is that equals to the right hand side? Definitely. So that also checks out. Therefore, x equals to 3 and y equals to negative 7 is the solution. That is the solution. Same story in this example number 4. We are still solving using the method of elimination. That is just the second example that we're going to use. Now we've got 2 equations. Now notice that the b's do not have the same coefficient, neither do the a's have the same coefficient. In this case, you choose which one you want to make have the same coefficient, which variable. Now I choose a in this one. So what you do is you multiply these two by numbers that will make them the same. For example, multiply 2a by 3, it will make it 6a, and then multiply this one by 2, it will make this 6a as well. And then you obviously will make sure that you multiply the rest of the equations as you do. Now, so what you do is you, step number 1, you go equation 1, multiplied by 3. That gives us what? That gives us 6a. So that is 2a multiplied by 3 minus 3b multiplied by 3 equals to 5 multiplied by 3. So 2a multiplied by 3 gives us 6a. Minus 3b multiplied by 3, that gives us negative 9b. And then 5 multiplied by 3 gives us 15. That is the first one multiplied. Okay, the second one multiplied by 2. 2 multiplied by 2. 3a multiplied by 2, that's 6a. Negative 2b multiplied by 2, that's negative 4. 20 multiplied by 2, that's 40. And then you write that down. So you go 6a minus 4b equals to 40. And now you subtract the second one from the first one. Why? So that we can eliminate this 6a or this a, and we're left with the rest of the equation. Hence the process of elimination, or the method of elimination. So we subtract minus sorry, let me fix that. So we start from the right as always. 15 minus 40, take out a calculator. 15 minus 40, that is equals to negative 25. So you write that down. It's negative 25. You write that down. 4b, negative 4b minus negative 4b. That is the same as negative 4b plus 4b. Let me do this on the side. Negative 4b, negative 9b. Let me fix that. Negative 9b on the side. So negative 9b minus negative 4b. That is equals to obviously negative 9b plus 4b. Negative 9b plus 4b, that is equals to negative 5b. So you're left with negative 5b over here. All right. 6a minus 6a. 6a minus 6a, that is equals to 0. So that gives you 0 over here. Which was the goal, by the way, so that we could eliminate. To eliminate is to get rid of. We could eliminate or get rid of the 6 or the a. Therefore, negative 5b is equals to negative 25. Therefore, divide both sides by negative 5. On the left hand side, the negative 5's cancel out with the negatives turn into a positive. Negatives turn into a positive. 5 goes into 5 once and into 25 5 times. Therefore, Therefore, b equals to 5. We've got b. Now let's figure out what a is. How do we figure out what a is? We're using the process of elimination. That means we substitute our b back into any of these equations. Now we choose the simplest one, which is negative with the first one. All right. So we'll not substitute b equals to 5 into 2a minus 3b equals to 5. 2a minus 3b equals to 5. We've got 2a minus 3b equals to 5. That's equation 1, right? That was equation 1, and your b is equals to 5. That's what we substitute. Okay, substitute into 1. You substitute into 2 if you want to. Go there for 2 times 5 minus, sorry, no, the a is, we don't have the a. Sorry about that. We substitute for b because that's what we have. So we leave the a's alone and we substitute the b. Alright, therefore 2a minus 15 equals to 5. Therefore 2a equals to 5 plus 15. Take the numbers to the right hand side, meaning that therefore 2a equals to 15 plus 5, that's 20. Now you divide both sides by 2. Okay, the 2's cancel out on the left hand side. And then here, 2 goes into 2 once and into 20 10 times. You can just use a calculator, go 20 divided by 10. I just want you to see exactly where everything comes from. You don't have to do things exactly the way I do them. Therefore, a equals to 10. And then you check, obviously. Check for equation 1 that both solutions hold, a and b. Then check solution equation 2 that both a and b hold. And therefore you go, therefore, a equals to 10. Okay, fix that. Therefore, a equals to 10 and b equals to 5 is the solution. And that answer is correct. Now the last method, which is the third method, is the method of solving the equation graphically. Now what you do is you'll be given a system of equations also with the variables. Now what you do is you plot both equations or graphs on the same set of axes. And before we do that, obviously you need to find what the coordinates are. So you take each of the equations. Okay, let's start with the first one and find the coordinates. Intercepts. All right, so for 1, we're going with 4y plus 3x equals to 100. Now to find the y-intercept, you must make x 0. Always remember that. Make x 0. So you go 4y plus 3, 0 equals to 100. And you're left with 4y equals to 100. Therefore, you divide both sides by 4. The 4's here cancel out. Then 100 divided by 4 is 25. Four goes into 4 once and into 100 25 times. Now therefore, y equals to 25 is the y-intercept for this graph. And then for the x-intercept, you make y0. X-intercept, you make y0. Y-intercept, you make x0. All right, so you go therefore 40 plus 3x equals to 100. Therefore, 3x equals to 100. Therefore, x equals to, divide both sides by 3, 100 over 3, which is approximately 33 and a third. 33 and 1 over 3. So the y-intercept is 25, the x-intercept is 33 and a third. Okay, so let's note that down. Y-intercept 25, x-intercept 23, 33 and a third. Okay, so let's note that down. Okay, for this one, y-intercept is 25, x-intercept is 33 and a third. All right, let's do the same thing for the other equation. Let's find what the intercepts are. All right, second equation, 4y minus 19x equals to 12. All right, for the y-intercept, okay, we make y0. So, we make x0. So 4y minus 19, 0 equals to 12. Meaning therefore, okay, 4y equals to 12. All right, therefore, divide both sides by 4. Y equals to 12 over 4 equals to 3. That's the y-intercept. Now the x-intercept, you make y0. All right, so you go 40 minus 19x equals to 12. Therefore, minus 19x equals to 12, meaning that therefore x equals to negative 12 over 19, which is approximately negative 0, negative 0, 6 if you use your calculator. So for the second one, right, let's write the information: 3 and negative 0 over 6. 3 and negative 0 over 6. Okay, for the second one, 4y minus 19x equals to 12. Okay, y-intercept is 3. And then the x-intercept is approximately negative 0.6. All right, now we go ahead and draw the graphs on a common set of x's. So we go, all right, we start with the one with 25 and 33 and a half. All right, we're going to plot that 25 and 33 over half. There is our 25. All right, okay, and then 33, and the third is, okay, that's 32. It's 33 and a third is somewhere there. Let's fix that. All right, let's fix here. must be on 25 on the y-intercept. And then over here it must be on 33 1/3. Okay, let's change the color and make it red. All right, that's the first equation, which is, okay, the equation is 4y plus 3x equals to 100. 4y plus 3x equals to 100. Y plus 3x equals to 100. 4y plus 3x equals to 100. That's the equation here. That's the equation here. The second one is, okay, the y-intercept is 3, and the x-intercept is negative 0.6. Y-intercept 3. Y-intercept is 3 somewhere here. 3. Okay. Then let's try the, that's negative 0.6 there. Somewhere there. Let's try and fix the other side. Let's fix this. All right, it should be. Okay, let's change the color to blue. This should meet right around there. Around this point where your x equals to 4 and your y equals to 22. This is where they should meet. Okay, let me try and fix that. Around this point, that's where they should meet. Okay, let me fix this one. Okay, that's the point they should meet. Okay, so basically all we need to do is manipulate this. Okay, so that's around where they should meet. This point here. The point is supposed to be negative. Okay, it's supposed to be 4 and 22. So that's the point there where they should meet. The point there is supposed to be, the x coordinate is 4 and the y coordinate is 22. That's the point where they should meet over here. Now let's see the graph I've prepared and drawn. Okay, let's zoom in. You will see exactly that point. There is the point. 4, using the equation editor, that is 0.4. That is 22. That is exactly the point where they should meet, and that, let me label that. The point here is supposed to be 422. And that's how you solve your simultaneous equations. We've come to the end of this video. Thank you for watching. See you on the next video. Bye.